This is the recording for topic 13.5, add and subtracting polynomials. Our objective for today is I can add and subtract polynomials. We're going to start with our bill work question. What is the solution to the following inequality? So in order for us to be able to find the solution, the first thing we need to do, we want to solve for x, but notice we have parentheses, so that means we need to distribute. I'm going to draw my line down our inequality sign, and then I'm also going to circle it because it's an inequality, I don't know if I'm going to have to do any switching. But let's distribute first. So we're going to distribute everything inside, so 6 times x is 6x, plus we also have 6 times 1, that is 6. Haven't done any division, so we're going to keep our inequality the same. It's greater than or equal to 7. Now we're going to continue on. We want to get the x by itself, so we need to get rid of the 6 that's not in the box. That means we're going to subtract 6 from both sides. Draw my little line. What's in the box comes down, so this is 6x in the box still. Positive 6 minus 6, that's 0. Again, we haven't done any division, so it stays greater than or equal to. And 7 minus 6 is 1. Let me start up here, rewriting. So now we have 6x is greater than or equal to 1. Again, does my inequality change? To get the 6 or to get the x by itself, we're going to divide both sides by 6. I'm dividing by a positive number, so my inequality does not change. I get that x is greater than or equal to 1/6. G is going to be my answer. Before we start, let's talk about what is a polynomial, because we are going to be adding and subtracting them. So what is a polynomial? A polynomial is an expression with variables and numbers. We've been dealing with those. But now it's where each term is separated by an addition or subtraction. These are examples of polynomials. Some of them are. Let's go with the definition. It says an expression with variables and numbers. Notice all of them have variables and numbers. But to be a polynomial, each term is separated by addition or subtraction. So when I look, I see 2 terms. Hey, it has an addition. This is a polynomial. This next one, we have 3 terms. I have subtraction, addition in between them, polynomial. We have negative 4 times x squared. I do not see addition or subtraction, so this is not a polynomial. 3x minus y, we have a polynomial. X squared plus 2x minus 3. It has addition and subtraction, it's a polynomial. 9x cubed minus x squared plus x, have addition and subtraction. 5a cubed, there's no addition or subtraction, it's not a polynomial. 2, no variables and no addition or subtraction, it's not a polynomial. And then last we have variables. And notice even though I don't see numbers, remember there's always an understood 1 in front of these that we don't necessarily show. So this does have variables and numbers, and there's addition going on, so this is a polynomial. So we can classify each polynomial even more specifically. Okay, we've already said if it just has 1 term, it's not necessarily poly, because poly means many, but it is a monomial, because monomial means 1. So I'm going to drag all my monomials over. Negative 4x squared, it's a monomial. No addition or subtraction. 5a cubed, another monomial. The number 2, yet another monomial. So 1 term, this is called a monomial. 2 terms, these are binomials. 2 meaning bi. And 3 terms, these are trinomials. So our 2x squared plus x, we have the addition, 2 terms, those are my binomial. X squared plus 2x minus 3, I do have addition, subtraction, there are 3 different terms, that's my trinomial. Negative 9x cubed minus x squared plus x, here's my subtraction and addition, I have 3 terms. X plus y, these are 2 terms. 3x minus y, there's 2 terms. And then a minus b plus 2c, we have 3 terms. So it's important for us to know how many terms we have, because when we're adding and subtracting, we have to line up, or we're going to line up our terms. I have a little visual here. We're going to stack them up. So when you see, notice I have a trinomial in parentheses. This trinomial has three terms and plus the signs between them. And then we have, again, in parentheses, three terms with the minus signs in between them. But the key here is what we want to do is figure out what's in between those parentheses. This tells us we are adding those parentheses together. So here's what I mean by stack them up. We have three terms. One of them has an x squared, an x, and then a constant. So I'm going to make three columns and separate my terms. So from the first parenthesis, I have a 2x squared. That's in my first column. Draw me a little dotted line, show columns. And then I have a positive 3x, and then draw another dotted line, and then a positive 2. So in my first row, this is in my first parenthesis. The second row is going to come from what's in my second parenthesis, but before I start, I'm going to use what's in between them. It says I'm going to be adding. So I'm going to put a plus sign in each one of my columns to tell me I am adding whatever comes next. So from my second parenthesis, I have an x squared. So I'm going to line it up with my 2x squared, put it right underneath, and then I'll remember, hey, the number in front of the x squared is a 1 if it's not shown. I've taken care of x squared. Next, I have a minus 5x, so I'm going to put in a minus 5x. And then last, I have a minus 5, so put it in a minus 5. So now I'm going back to elementary school when I learned how to add and subtract. I'm going to do it up and down. So there's my little line for my equal to. And I know that I am adding. And in my columns, when I add like terms, recall from way back when that when we have like terms, meaning they have the same variable with the same exponent, I'm adding the numbers in front. So 2 plus 1 is 3, and then I keep the same variable in the same exponent. That is 3x squared. Now I'm in my second column, and here's where my calculator will come in handy, especially if you still get confused about what happens when I add positive and negative numbers together. So notice I have a 3x, it's positive, and then I have plus. I'm doing a, now that it's in the middle, I'm going to call it a negative 5x now that I've separated it. So I have a positive 3x plus a negative 5x. Notice we have more negatives than we do the positives. So this means I'm going to end up with a negative number. And I have two more, because this is really, let me just use my calculator to show you what I mean. So I'm going to use my calculator, and I am going to type in the calculator exactly what I see here. Now when we start off with a plus, I don't need to show it, but I'm just doing the numbers in front of the variables, the coefficients. So I have a 3, then I have a plus, because that's what we had in between our parentheses, plus. And now, since this number comes second, instead of putting a minus 5, I will put a negative 5. So my calculator is going to do all the fun things as far as when I add numbers that have opposite signs. And this gives me a negative 2. So I'm going to put negative 2 as my final answer in that column. It also has an x because everything in that column has x's. Then in my last column, I have a positive 2, so I just put a positive plus. I don't need the plus. And now I'm going to add to it a negative 5. So negative 5, 2 plus negative 5, that is a negative 3. Now I have added what is in both of these parentheses together, and this is my final answer. I'm going to rewrite it without the little dashed lines in between. This becomes 3x squared minus 2x minus 3. So this is what I mean again by let's stack them up. Our second example, we have 2x squared plus x minus 4. That's in our first parenthesis. This time we will be subtracting. Notice what's in between them is a minus sign. We're subtracting x squared minus 4x plus 1. So I'm going to start again, but what's in my first parenthesis? We have a 2x squared, a plus x, and a minus 4. I'm separating my terms, so all my x squareds are together, my x's are together, and my constants together. This time, though, in the middle, I have a minus sign, so now I'm going to put minus, minus, minus in each column, because I have to subtract everything that's in that parenthesis. So now I'm going to put a 1x squared. Next, I have a minus 4x, so I'm going to put a minus 4x. And last, I have a plus 1, so plus 1. Now again, I will use my calculator. And now I have the first column, 2 minus 1. That one's no problem. That leaves me with 1. And then I keep the x squared. This next one might be a little more difficult. Again, the number in front of the x is positive, or sorry, is a 1. So positive 1, I just type in as 1. Now I'm going to do a minus because I'm subtracting. And then I'm subtracting a negative 4. 1 minus negative 4, that's a positive 5. So we get a positive 5x. And then on my last one, so this was when I read it, I said minus 4, but now that I've separated it, when I type into the calculator, if my first number has a minus sign, I type in a negative. So negative 4, then I have a minus, and now positive 1, I don't need to put the positive, I can just put a 1. I don't need to put the plus. And I type that in and press enter. This is a negative 5. And there are no x's with this one. So now I rewrite it. I have 1x squared. Since this 5x is positive, we put plus 5x and then minus 5. So we are combining like terms by stacking them one on top of each other. Let's do some more examples. Another way that we can ask a question, we have a figure with some sides that are polynomials, and then we want to find the perimeter. And the way we find perimeter is we add all sides. So let's start with one of the sides. I'm going to label it. This is side number 1, side number 2, side number 3. So this time when I do my columns, I should have 3 items in each column. So let's write the first side first. We have 3x squared, on my little dash line for the column, then a negative 4x, and then last we have a 7. Taking care of my first one. Now, it's because it's perimeter, we're adding, so we'll say plus, plus, plus. Let's go to our second side. Our second side is a positive 1x squared, and then a plus 3x, so I just leave 3x as a positive, and then a minus 5. We took care of side number 2. Side number 3, we're going to add plus, plus, plus. And now we have 2x squared from that side, 2x squared, a positive 4x, and a positive 1. Now when we add them up, just like in elementary school, we're going to add going up and down. So let's add our coefficients. First column, we have 3 plus 1 plus 2. Most of you could do that in your head. That gives us 6, and then we still have an x squared with it. The second column, I start off with a negative 4, so we're going to do a negative 4 plus 3 plus 4, and it gives us a positive 3. Still have an x there. And last, we have 7 plus a negative 5 plus positive 1 gives us a positive 3. So when we answer this question, the perimeter is equal to the polynomial 6x squared plus 3x plus 3. It's a polynomial because we don't know what x is yet. Number 4, we have if the perimeter of the triangle is given. So in this case, they're giving us the perimeter. It's 6x squared plus 5x minus 5. And they're giving us 2 of the sides. So here's side number 1 is x squared plus x plus 1. And our side number 2 is 2x minus 1. We want to find what's the length of the third side. That's the one we don't know. I'm going to show you how you can still stack them up and use the stack them up method to help you figure out what the third side is. A lot of my students prefer this method over the alternative, which is I'm going to add these 2 sides together and then subtract, but I kind of don't like to do subtraction as much, so we're going to do the stack them up method and see how that works. All right, so let's start off just like we did before. I need my side number 1. Side number 1, they tell us, is x squared plus x. So let me go ahead and put my 1's in there. And then my last column is going to be a plus 1. All right, we took care of the first side. Let's take care of the second side. Side number 2, notice I don't have any x squareds. So I'm going to put a 0 x squared because I don't have any. But then I have a positive 2x, so I'll say, oh, I forgot to do my pluses. Plus, 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 because we're adding everything together. So now I have a positive 2x. I just put a 2x. And then I have a negative 1. So I took the 2x, and then the last is the negative 1. I took the sign with it. So again, we were adding. Third side, we need to add plus, plus, plus. The thing is, I don't know what the third side is. So I'm going to leave it blank, blank, and blank. But when I draw my line to say let's add them up going up and down, this bottom is my perimeter. And they told me my perimeter has to be 6x squared, and a positive 5x, and a negative 5. Still separating. So now let's use your brain in two ways if you can ask yourself. 1 plus 0 is just 1. So 1 plus what number would I need would give me 6. Or some of you might realize, hey, can I do 6 minus 1? And that'll tell me what that number is it has to be. So we can see that, hey, I have to add a 5 there in order to get 1 plus 5 to get to the 6. Let's look at the next one. I have 1 plus 2. So 1 plus 2 is 3. What do I need to add to 3 in order to get to 5? I'm going to need another 2. I did the wrong thing. I need another 2. Let me check. 1 plus 2 plus 2. That definitely gives me 5. In the last column, I have 1 plus a negative 1. That comes out to be 0. So 0 plus what number is going to give me a negative 5? So 0 plus a negative 5 is going to give me a negative 5. Let me check. 0 plus negative 5, and sure enough, I get my negative 5. So the answer I'm looking for is the third side. My third side is 5x squared plus 2x minus 5. All right, our next thing is we want to find the area of the shaded region. So, find the area of the shaded region if 9x squared minus 6x plus 3 is the area of the total region, and 3x squared plus 2 is the area of the unshaded region. So this little piece here is 3x squared plus 2. We want to know what the shaded is, but we know that the total is 9x squared minus 6x plus 3. So in this case, to do the unshaded, we are going to go ahead and do some subtraction. Let's do unshaded area. We want to find the shaded. So the shaded is equal to our total area minus the unshaded region. Taking the total minus the unshaded. So our total is 9x squared minus 6x plus 3. And we want to subtract the unshaded. Now, unshaded is the total amount, 3x squared plus 2. So let's stack them up and see what we come up with. We have 9x squared, my first column, negative 6x in the second column, plus 3. That's my total we took from the whole thing. Now we're going to minus, 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 because that tells us to subtract. What we're subtracting that comes next, we have a 3x squared that's going to go under the 9x squared. And then we have a positive 2. So I'd put a positive 2 at the end. Notice we don't have any x's, so we're just going to say 0 x's. Now that they're stacked, we can do 9 minus 3. That gives us 6x squared. And now we have a negative 6 minus 0. That'll give us a negative 6x. And then a positive 3 minus 2 is a positive 1. So this tells us that our shaded region then is going to be equal to 6x squared minus 6x plus 1. Number 6, we want to find the total area of the figure. So this figure is a composite figure with 5 different parts. We have the squares on the end that are y squared, and we have this rectangle in the middle that has an area of 13y squared plus y plus 4. So to find the total, we add them all up. So let's start with the one that has the most terms. The one that has the most terms is this rectangle in the middle. We have 13y squared. Again, I'm going to stack them up. We have a positive y. There's a 1 in front of that. And then followed by the plus 4. Takes care of the big rectangle. Then we have a small little square on the top left, so that is 1y squared. We'll add, add, add. That took care of that one. Then we're going to add the one on the right. That's another, don't forget my squared term, 1y squared. Bottom left, plus another 1y squared. And lastly, bottom right, plus a 1y squared. So we have all our terms, and I didn't have any other y's, and I didn't have any other constants, so I'm just going to put big old zeros. So let's add up how many y squareds we have. We have 13, 14, 15, 16, 17. So 17y squared plus 1 plus 0 is 1. So it's 1y. And then plus 4 plus 0 is 4. So the total area is 17y squared plus y plus 4. What you have seen is the stack 'em up method in order to add polynomials. This concludes the topic of 13-5, where you can now add and subtract polynomials.